Hello. In this video we're going to be looking at the last lecture within chapter 19. Lecture 19, we're going to do a pre-lecture video. So a pretty quick video going over all the things we're going to be going over in the lecture. So in this lecture we're going to kind of focus on molar entropies, standard molar entropies, Gibbs free energy. We're going to be looking at both standard and non-standard Gibbs free energy, and then looking at our equilibrium constant in conjunction with our Gibbs free energy. So our standard molar entropies, we do delta S naught of reaction for those, or system if you will, and we can solve for this using a table. So we have a table full of, so it has values of our delta, or our S naught, our molar entropies. So using these values of S naught, we can solve for our delta S naught of reaction, where delta S naught of reaction is equal to our S naught of our products minus our S naught of our reactants, taking into account stoichiometry. So if we have reaction AA plus BB goes to CC plus DD, our S naught of our reaction would be equal to A times by S naught of A plus B times by our S naught of B minus, not A, these are reactants. We need products. C, C, D, D. There we go. And now we have our reactants, A times by the molar entropy of A plus B times by the molar entropy of B. And from here we can solve for our S naught of our reaction. We can then turn our attention from entropy, and we're going to look at Gibbs free energy. So G of our reaction, so G is Gibbs free energy, and the most common reaction, or the equation you guys are probably familiar with, is this one right here. Our G of our reaction equals delta H of our reaction times by T delta S of our reaction. We have a standard form of this, which we'll use a lot. So we can solve for these quantities using the idea that products minus reactants give us those values. So we can just use a table of formation enthalpies or standard entropies to solve for our delta G of our reaction. And we could also do the same thing we did up above, where we take our delta G of our reaction and use formations. So same equation we used above, but now we have delta G naught Alright, so we can do the same exact equation, and this is the same equation that we did for delta H in Gen Chem 1. So we can solve for those reaction values using the formation. So these are formation values given in a table. So, like the table I gave you guys. So right here, this has all those values in there. So you use those tables to solve for those. And you could do the same thing for your delta H of your reaction. where these are delta H, let's try that again, delta H naught or formation values given in a table. Okay, so we can solve for all of these very similar ways. So the first part of this lecture just talks about solving all of these values. Next part we look at non-standard G. So looking at non-298 Kelvin at not 1 atmosphere of pressure. So with our non-standard, that's equal to our standard delta G plus RT ln of Q, our reaction quotient. Okay, so remember your reaction quotient, talking about the same equation. Generally with these you're looking at partial pressures. Although not always. So, not at equilibrium. And this is if all are gases. We use this. But if all our substances or most are aqueous, then we'd use Q is equal to our concentrations, right? But again, not at equilibrium. Okay. So we can, however, look at a system at equilibrium. So if we are at equilibrium, we can take that initial equation, and at equilibrium, our non-standard delta G is equal to 0. And Q is equal to K. So we get 0 is equal to delta G naught plus RT ln K. And we subtract RT ln K from both sides, and we get delta G naught is equal to negative RT ln K. And we can also actually solve for our delta G if we know our equilibrium constant, or solve for our equilibrium constant if we know our delta G. So these are the equations that you guys will be using for this lecture, and this is a very, very short lecture, so of course it's a very, very short pre-lecture video. Okay. And that's everything. That's all of lecture 19.